So as we look at this chapter, you notice this picture here. It says segments of chords theorem. It says if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So that looks very similar to the one we did last week where I asked for an angle. And I said if I wanted to find this angle, you'd take this arc, add it, and divide it by 2, right? But this one's not looking for angles, or it's not even using arcs. This is looking at chords. So always read the question or look at the problem. If I have numbers that are inside, like the way they are here, then you're looking at segments, okay? If there's no degree on the problem, then you're looking at segments, okay? Now, the formula says part by part equals part by part. What I mean by that is you take one part of the chord, so I'm going to take the 5, and I'm going to multiply it by the remaining piece of that chord. What's the remaining piece of that specific chord? 12. So you do 5 times 12 equals, all right, and then what do we multiply here? I'm going to do x times the remaining piece, which is 10. And then you multiply and divide. That's all it is. So the hardest thing is not necessarily doing this, it's distinguishing when are you doing this formula, when are you doing the other formula. All right, so what is 5 times 12? 60. And what's 60 divided by 10? X is 6. Okay. All right, think of a proportion, right? When we had proportions, let's say I had 1 over 2 equals 5 over 10. I lied, not 10. Let's do x. You would do 2 times 5 is 10. 1 times x is x, and then divide if you needed to, right? It's the same thing as a proportion. You're just not needing to do this piece right there. It's just this part that you're doing. All right, so I have 15 on one chord. What's the remaining measurement of that specific chord? 12. All right, equals, pick any piece of the other chord. Doesn't matter which piece you pick. If I want to pick x, I do x. X times, what's the remaining piece of that chord? 18. All right, all you do is multiply. Can someone give me 15 by 12? 180. And then this would be 18x, so x has a value of 10. All right. All right, so just like the last part of the proportion, all right? So I want you to go ahead and try. Let's try A. Now I want to see how many of you guys can do B. If I'm going to go over them anyway, right? So let's just try A and B and let's see how far we get. What did you do for A? 4 times 15 equals? Yeah, there you go. The 6 times the x. Good. And what does that give you? The next line. Good. So then what's your x value? X equals 10. Do we all agree it's 10? All right. It's 10. All right. All right. What would I multiply for B? What would we multiply? Go, David.
X times x plus 12
Mm-hmm.
equals x plus 6 times x plus 2.
Okay, we saw this when we found the radius. Remember we had to do the FOIL method or the double distribution? All right, what did we get on the left side when we distribute the x? 12x, good. What about when we distribute this x? What do we get? Good, and then you have to distribute the 6. What do we get when we distribute the 6? Good. Combining like terms, how many x's are there? What would be 6x plus 2x? 8x. What happens to the x squared when I decide to move it over? It cancels out. Interesting. It doesn't have to all the time. We could get a quadratic and then do the quadratic formula, but I don't know if your teacher covered it last year, so I took that part out for y'all. All right, then I have to move the 8 over. How do I move the 8 over? Subtract it, so it would be the difference of 12 and 8. 4. So then x has a value of 3. Okay. All right, how does that one feel, that formula? Okay, I don't think it's necessarily hard. Again, I think it's knowing when do you use this formula, when do you use the other formula. Again, if there's no degree, you're using this one. If there's a degree anywhere, so if y'all had let's say, same picture, but you had 70 degrees, you had an X, and you had 50 degrees, then that's your cue you're looking for an angle. So that would be angles, the angle section on our formula chart, okay? Because they do look the same, looking for different things. All right, this one, it says the true shape of a rainbow is a complex circle. However, we only see the arc of a circle when it appears above the Earth's horizon. What's the radius of the circle? So what this is, and this usually gets the kids, it's just a circle, but they didn't finish the circle. So I want you to go ahead and finish your circle. I gave y'all some room there on the notes at the bottom. The best that you can, okay? This is the same problem we were just looking at. Y'all have a chord here that says it's 5 miles, and it also has these important markings there. And then you have this line here, but could I say that's the radius? No, I don't know what that is, but I know it's not the radius because this whole thing right here is the diameter. And if I had a sketch, I'd say about the center of the circle would be about there. So then the whole chord there is 5. So if they're congruent, what would each piece be? 2.5. And now you're back to our problem. Now, if I take everything away and only add what I actually need, this is what you have. You have this missing, you have 0.7 here, and you have 2.5 there. Exact same problems we were looking at. Without the rainbow, without the water, without that extra box. That's all it is. Okay? So if I take the same formula we were just using, what would I multiply here? You take one piece and you multiply it by the remaining piece. So what would I multiply? 2.5 times 2.5. All right. Do the same thing with the other chord. With the other chord, we're going to look at what number? 0.7 times x. 0.7 times x. All right. What's 2.5 times 2.5? 6.25. And then dividing by 0.7, what do we get for the x value? 8.92. Now, all of this was x. They wanted to know what was the radius of this whole circle. So is the answer 8.92? No, what do I have to do with that 8.92? Add 0.7. Yeah, you got to add the 0.7, that little bitty piece that we started off with. So now what's the total? I got 9.62. Is that what you got? Okay. And then you divide that one by 2. What do we get? All right, and then that's your radius. So on this side here, this looks very similar to the one we looked at. Again, they're two different things. So the one we've looked at before has a secant and a tangent, or vice versa. But that one had the big arc minus the small arc divided by 2 gave us angle A. Do you remember that one? Okay, same thing, same picture, different topic. This time, they're looking at not the angles, but they're looking at the length of the segments. So when you look at the length of the segments, you're going to look at the external secant, which is out here, and you're going to multiply it by the whole thing. So if you notice the formula, it says the outer times the whole. Again, it's the outer times the whole line. That's all it is. And then you just set them equal, multiply, and solve. Okay, so find me one outer piece. What number's on the outside of the circle? 6. Okay, I heard 6. 6 times, what's the length of that whole secant? 16. So 6 times 16 equals, what number's on the outside on my other secant line? Outside number. What is it, Aiden? 8. 8 times, and then what's the length of that whole secant? X plus 8 or 8 plus x, either one. All right, who can give me 6 and 16? 96 equals 8x plus 64. All right, let me know what you get for your x value. What'd you get, Ethan? 4? Everyone get 4? 4? All right. It's been confirmed. X is 4. All right, let's look at the next one. Same thing. Outside hole, outside hole. All right, so let's see. Sophia, give me a number that's on the outside of my circle. She says 4. All right, so I'm going to multiply 4 by what, Jolette? What would that whole thing be? 12. All of it's 12. So you're going to say 4 times 12 equals. All right, Jocelyn, what's on the outside on my other secant line? 3. And then how would I name that whole secant line? X plus 3. All right, let me give you a minute to go and solve that one. Let me know what you get for your X value. All right, Kasavian, what'd you get? 16? Did you say 16? Oh, no, okay. It's okay. David, what did you get? 13? James, did you get 13, James? Yes? Okay, James said yes, so I'm going to go with James. James said it was 13. All right. All right, I'm going to have you guys just do one. All right, just do one of these. They're the same. The difficulty is the same, so just do one. Athena, what did you get for your X value? 16.66 repeating? Dom, what'd you get? 16.166 repeating? Okay. All right. It's okay. It's an ugly decimal. We can live with it. All right. Last thing. It's going to go over to the back side. So on the last one, it's kind of making up for not having a whole secant. This is a tangent secant theorem. Still looking for these segments. All it's doing, one side stays the same, where it's the outer times the whole. It's this outside times the whole thing, just like we just finished doing. This side's kind of making up for not having that secant. So it's going to square that one tangent piece that's all by itself. So I recommend with this one, finding your tangent piece first. What's the tangent piece here? 9. The 9. Take that one gets squared because it doesn't have the full line. Think of it that way. Doesn't have the full secant line, so we're going to kind of make up for it. The second part is set up exactly like we just finished practicing. What number's on the outside? 5, and the whole thing is 5 plus x. Good. All right, so then we got 81 equals 25 plus 5x. Let me know what you get for your x value. 11.2? Yep, all right, 11.2 it is. 11.2. All right, now again, identify the one that's by itself. Which one's by itself? That one gets squared. All right, the other one's the same way we've been doing it. Which one's on the outside? 9. And then you have to add the whole thing together. Can I simplify x plus 1 plus 9? What does that come out? Give me. X plus 10. All right, so 225 equals 9x plus 90. What do we get for the x value? Angel, let me know what you get for the x value, Angel. What is it? 15? 15? All right, 15. All right, this one didn't work out the way I wanted to. Go ahead and cross this one out. It had it was a quadratic, and I'm not doing quadratics. This one, let's go ahead and solve this one together. Who can help me set this one up? Which one am I squaring? The x, the one that's all alone, making up for being alone, all right? All right, what am I putting on the other side? Steven, what do I put next?
3 times.
Perfect. 3 times the whole thing.
Oh, yeah. 3 times 12.
Times 12. Good. What's 3 times 12? 36. And then how do I get rid of the square? Square root in. X is equal to 6. Good.